Everyone, my name is Amin, and today I will be presenting my thesis, which is entitled "Exploration and Mitigation of Stereotypical Gender Biases in Information Retrieval Systems." But before I start my presentation, I would like to thank my supervisors, Dr. Ibrahim Bagari and Dr. Murtaza Zihayat, and all the great colleagues that I have the opportunity to collaborate with. So as you all know, the task of information retrieval is to satisfy users' information need based on the submitted queries to different search engines. And researchers have tried to improve the performance of retrieval models on research data sets such as MS Marco. And during the past years, they could have achieved great performance in terms of retrieval effectiveness. So everything is good, everyone is happy. So what seems to be the problem here? The problem is that when a user refers to a search engine, such as Microsoft Bing, and searches for some fairness-sensitive queries, such as how to become a police officer or how to become a nurse, the results are biased towards a specific gender, and this can result in unfair prejudices and wrong decision makings. The same thing happens for textual data as well. So, for example, as you can see here, when the submitted query is how important is a governor, among the top retrieve list of documents, we can see this document that is representing the male gender as the only gender identity that can take this position, or the same thing happened for manager position. So in order to explore the level of gender bias in IR systems and try to reduce these gender biases, we need to first quantify a metric for measuring the level of bias. As a simple method to measure that would be to calculate the term frequency of male terms and female terms within a list of words in a vocabulary, and calculate the magnitude of male terms subtracted by the female terms, and calculate the bias of a specific document. And by having the bias of each document, we can then calculate the level of bias within the retrieved ranked list of documents for a specific query. And using that, we can quantify the level of bias over the ranked list of documents for different queries within our dataset. So this is one of the metrics that is used for measuring the level of gender bias. Another simple approach would be, actually alternative approach would be to measure the fairness within the retrieved list of results. So in order to do that, the neutrality of documents within that ranked list of results will be calculated, and fairness and bias are opposite to one another. So higher fairness and less bias would be desirable. So having these metrics, researchers have done different research studies to evaluate the level of gender biases in retrieval methods. For example, Rekopsas et al. Gathered a bunch of non-gendered queries by labeling those queries using Amazon Mechanical Turk, and measure the level of bias within the ranked list of documents that were retrieved using different retrieval methods, so such as BM25 and neural-based ranking models such as BERT. And the results indicated that neural ranking models intensify the gender biases within the ranked list of documents. So The bad news is that gender biases exist within information retrieval systems, and the objectives of this thesis is basically reducing those biases. Within the context of information retrieval systems, there are at least two components that can cause these biases. The first component would be relevance judgment collections of IR system that are basically the gold standard data set that the neural ranking models gets trained based on. So if these gold standard data sets are biased, then they can transfer those biases into the representation and algorithmic aspects of the neural ranking models. And the second component would be the search methods themselves. So the objectives of my thesis are exploring gender biases in IR relevance judgment data sets, and based on the results, we show that those biases are prevalent among gold standard data sets and are capable of getting transferred into neural ranking models. And I proposed a methodological approach for debiasing those gold standard data set for having fair neural ranking. And I also proposed methods for reducing gender biases within different classes of retrieval methods, namely term frequency-based retrieval methods and neural-based retrieval methods. Due to the time limitation, I'm not going to go over the approach that I proposed for reducing biases in relevance judgment data sets, and I will only focus on my proposed methods for reducing the level of biases within retrieval methods. So the first class of retrieval methods is term frequency-based one. And the approach that we have proposed for this method has been published at SIGAR 2021. So one of the term frequency-based retrieval methods is pseudo-relevance feedback. And the idea of pseudo-relevance feedback is to revise the original query that was submitted by the users to the search engine using the most informative terms extracted from the top-tier retrieved documents. So when the initial query is submitted to the search engine, an initial retrieved list of documents is returned for that query using a lightweight retrieval model such as BM25. And then from the top K documents, most informative terms using TF-IDF are selected and are appended to the initial query to expand that query. And then that expanded query will be submitted to the search engine again, and the retrieved list of documents will be shown to the users as the final list of documents. So the problem here is that when those terms are getting selected from the top K documents, it's possible that some biased terms gets appended to the query. For example, if you have a fairness sensitive query and the top retrieved list of documents are biased towards a specific gender, then those appended terms may be some words such as he, she, and they can change the gender identity of that query. So the hypothesis of this work is that less biased query would result in less biased retrieved list of documents. And the objective is to propose a bias-aware pseudo-relevance feedback framework for expanding the query. So the way that this bias-aware pseudo-relevance feedback works is that when the query is submitted to the search engine and the initial retrieved list of results are returned, instead of what we do is that we first measure the level of bias within each of those documents, and then we re-rank the initial list of results based on their relevance score and their bias score. And this lambda here is a hyperparameter that one can investigate the impact of. And Now, what we do is that we re-ranked the retrieved list of documents based on the relevance score and the bias score. And this time we select terms from cupcake documents that are less biased compared to the original one. And and this way we can expand the query to generate a bias-aware query. And these are some of the examples that you can see. So this is the original query. This is the original pseudo-relevance feedback framework. And this is our approach, which is bias-aware pseudo-relevance feedback. So as you can see, there are cases, such as the first one, that the baseline revised query have introduced additional bias terms to the query that are not seen in our proposed approach. And in other cases, where bias terms appear in both forms of the revised query, the weight of these terms are much lower in our proposed approach. And those weights can also be impactful on the final list of results that are returned. And our findings indicate that using this approach, you can still get the same retrieval effectiveness, which means that you can still satisfy the information need of the users in a perfect way. However, the degree of bias reduces significantly, which means that you will satisfy the information need of the users and at the same time expose those users to less biased list of documents. So this was my approach for reducing gender biases in term frequency-based retrieval methods. The second part would be reducing gender biases in neural ranking models. And this work has been published at DCR 2022 and could receive the Best Paper Award at this conference. So the concepts of neural ranking models is that we use pre-trained language models for the task of retrieval. And the way that we do this is that when the initial query is submitted to the search engine and a list of results are returned for that query using a lightweight retriever such as BM25, what we do is that we take a specific pre-trained language model such as BERT model and fine-tune that model based on the triples, that these triples consist of the query, the positive passage, which is the relevance judged document for that query that comes from the gold standard data set, and one of the other documents that have been returned for that query. And the goal is to fine-tune the model in a way that it can learn the mapping between the query and the document. And we want to learn the concepts of relevance using this training procedure. So the problem here is that when you train specific models such as BERT, based on the data that you have, those pre-trained language models have captured societal biases based on the data sets that they have been trained previously on. And they will also capture some of the bias, some of the gender biases from the data set that you use for fine-tuning those models. So the way that we propose is somehow can be named negative sampling strategy. So researchers have shown that the performance of these neural ranking models are very sensitive to the adopted negative sample strategy and can be increased by 70%. So it means that the documents that you show as the negative samples to the model can also be impactful on the performance of the model. So what we hypothesize is that representing biased documents as negative samples can make neural ranking models aware of avoiding gender biases. So the objective of this part is to propose a bias-aware negative sampling strategy that helps the model to not only learn the concepts of relevance, but also learns to avoid the biases that needs to be avoided at the time of re-ranking the initial list of documents. And the way that we do this is that when the query is submitted and the initial list of documents are returned, we measure the level of biases within each of those documents, and then we rank the documents based on their bias score. So we would have some negative samples that are biased and some negative samples that are unbiased. And then instead of selecting the negative samples randomly, which is used in the original training procedure, we select our negative samples from the sets of biased documents and unbiased documents. And this way, we help the model to learn the concepts of irrelevant and the concepts of biased documents that needs to be avoided at the time of ranking. And we have a free parameter like lambda that determines how many documents needs to be selected from biased category and how many documents need to be selected from biased documents. And we have explored the impact of lambda on BERT model's performance on MS Markov deficit. And we can see that when the lambda is greater than 0.6, the retrieval effectiveness starts dropping significantly. So we take the lambda as 0.6, which means that 60% of the negative samples are selected from the pool of biased documents, and the rest will be selected from the pool of unbiased documents. And we have also investigated the retrieval effectiveness on different neural rankers such as BERT, Roberto, and Electra. And as you can see, when we use our training schema for fine-tuning these neural models, we can see that the retrieval effectiveness still remains at a comparable level to the base ranker. So it means that this approach doesn't hurt the retrieval effectiveness of those neural ranking models and can still satisfy the information need for us. However, when we compare the level of fairness, we can see that while the retrieval effectiveness has remained in a comparable level, the level of fairness has increased significantly. So we could have present a fair list of documents, or let's say more fair list of documents to our users and keep the retrieval effectiveness at a comparable level. And in comparison with the state-of-the-art methods such as AdVert that also tries to reduce gender biases using additional components, using an additional adversarial component, we can get better results in terms of the fairness and the retrieval effectiveness, because the level of fairness has been increased in our proposed approach better, and the retrieval effectiveness has been also better in our proposed approach. And the advantage of our proposed method is that, as I mentioned, decreasing the level of gender biases doesn't come with the cost of reduction in retrieval effectiveness. And the good thing about this method is that you don't need to change the architecture of the loss function or the model for reducing gender biases. So it can be applied towards any neural ranking model. And one of the good things about that is that it can be used for other attributes such as race, color, and those things. So it's not just limited to gender. And we also investigated the retrieval list of documents. So for the same query, how important is a governor? When you use the original base ranker for re-ranking the documents for this query, you will get this document in the third level. However, when you do the ranking process using our proposed approach, the ranking position of this document goes to 22nd. And for this one, it goes from 2nd to 88th. The implications of this study is that the proposed methods can be used or can pave the way for researchers to use the methods or try to improve them and use them in current search engines. It can also be good for enterprise environments where companies want to use low-cost methods for exposing their users with less biased list of documents, and it can also be used for educational purposes. Thank you so much, everyone, for your time and attention. If there is any questions or comments, I would be very happy to answer.
All right, questions for Amin?
I see Ian with his hand.
Oh, sorry, still clapping again. Another good presentation.
Yeah, that was really good presentation. I have one question. I don't know. Do we have another hand? Sorry, I don't. Shane, sorry, go ahead.
Oh, that's all right. I was just wondering if this method was worked for images as well, or because you showed images at the beginning, but just went to the text example.
Thank you so much for the question. No, the methods that I proposed would only work for textual data. I just used those images for showing that these problems exist in a broader way.
Okay.
There is a need for research to also reduce bias in image data as well.
I have a question. I mean, I just want to understand how your negative sampling look like. So when you have your negative, your bias document, so it could be that the document is giving the right definition, but it's just loaded. So you have your bias score. So it's a higher score in the bias, right? So it's not about what the document is describing.
So the thing is that we select those biased documents among the irrelevant documents. So within the context of information retrieval, the gold standard data set determines what are the relevant documents for that specific query and what are the irrelevant documents. And we have nothing to do with the relevant documents, which means that the model is still able to learn the concept of relevance. And we try to present those negative documents that are irrelevant and at the same time contains biases towards a specific gender.
Thank you. Thank you.
Thank you so much for your question. Thank you.
All right. So thank you very much again, Amin.